Hello guys, in this video I'm gonna explain section 4, sum and difference identities. We have a bunch of identity here, sum identities and difference identities. For both of them we have 3 identities. So for sine A plus B, the identity is the expansion is equal to sine A times cosine B plus cosine A times sine B. So if we have plus in here, we have plus in the expansion. If we have minus in here, we have minus in the expansion. For sine, the function sine, we have sine and cosine together, sine and cosine together. But for function cosine, it's different. For the identity cosine A plus B, the expansion is cosine A times cosine B minus sine A times sine B. Unlike sine, we have addition between first here. In the expansion, we have subtraction. If we have subtraction inside, in the expansion, we have addition. The signs are different. Unlike sine, in function cosine, signs are different. And the other difference here is we have cosines together, sines together. But for function sine, you have sine and cosine together. But cosine function, the expansion here, cosines together, sines together. Tangent is different than others. So tangent A plus B, the expansion is tangent A plus tangent B over 1 minus tangent A times tangent B. If you have negative in here, you'll have negative at the top, positive at the bottom. When you have positive here, positive at the top, negative at the bottom. When you start solving questions, when you solve many questions, you'll get used to them. Don't worry about it. Find the exact value of each expression. So the idea here is we are given an unknown angle. So far we worked with special angles, some famous angles, but this angle is a mysterious angle. All I have to do here is write this mysterious angle in terms of sum or difference of 2 famous angles. So how can you think about 105 degree here? How can I write 105 in terms of sum or difference of 2 famous angles? So cosine 105 degree can be written as cosine of, I think of angles 45 and 60 here. So sum of 45 and 60 will make 105. So I can use that 2 special angles here to find the value of this unknown angle, the value of cosine 105. So let's solve this question by using the identity. Here is question 2. So let's do the expansion. It's equal to, so that's cosine and there's plus between them. Cosine, there's plus between them. So I'm going to multiply cosines together. So cosine 45 times cosine 60. Since I have plus here, I'll have the opposite operation here. I have addition here. I'll have the opposite operation here, which is subtraction. Minus, now I'm going to multiply sines together. Sine of 45 times sine of 60. Now let's write values of each trigonometric function one by one. So cosine 45, square root of 2 over 2. Cosine 60, 1 over 2 minus sine 45, square root 2 over 2 times sine 60, square root 3 over 2. Let's simplify that. So square root 2 times 1, square root 2 over 2 times 2, 4, minus square root 2 times square root 3, square root 6 over 4, and write it under the same denominator. So square root 2 minus square root 6 over square root of 4. That's your result. If you know identities, you can solve questions easily. Let's continue with question 3. Sine 11 pi over 12. So if you don't know what that means, you can write it in terms of degree first. So 11 pi over 12. 11 pi over 12 in terms of degree. Multiply it by 180 divided by pi. So simplify it. So pi's will go. When you simplify it, you're going to get 165 degree. So how can you think of 165 in terms of two familiar angles? I can write it as sine of 165 degree equals sine of, I'm going to use either sum of two famous angles or difference of two famous angles. What I think of here is 120 and 45. So these two angles should be either spatial angles or whose reference angle is spatial angle. 45 is spatial. You may say that 120 is not spatial, but its reference angle is spatial, so you can proceed. So the expansion for sine, an angle plus another angle here is sine times cosine together plus sine times cosine. So sine 120 times cosine 45 plus, you have addition here. So in the expansion you have also addition since it's a sine function. Plus sine of the other angle, I used 120 for sine here. I didn't use 45 for sine, so I will use 45. I used 45 for cosine here. Now I'm going to use 120 for cosine. So let's write their values one by one. So sine 120, the reference angle is 60. Sine 60 is square root 3 over 2. 120 is in the second region, so the sign is positive. Times cosine 45, square root 2 over 2. Plus sine 45, square root 2 over 2. Times cosine 120, reference angle is 60. Cosine 60 is half, but since it's in the second region, the sign is negative. Be careful about that. So it's going to be equal to square root of 6 minus square root of 2 over 2 times 2, 4. That's it. Let's move on to question 4. Pi over 12. It's written in terms of radian. If you don't know what it is in terms of degree, just convert it. So pi over 12, pi over 12 multiplied by 180 over pi. Pi's will go 180 over 12 will give you 15. So here we have tangent 15. So how am I going to think about 15? How can I write 15 in terms of two spatial angles? So there are many ways of thinking about 15 in terms of two spatial angles. One of the ways is thinking of 15 as being equal to difference of 45 and 30. You can use 60 minus 45 as well. It also gives you 15. It's up to you. So 45 minus 30 is 15. I can use that. So let's take a look at the identity. Here is the identity. Tangent A minus B. I have subtraction here. So I'm gonna use this identity. Tangent A minus tangent B. So it's equal to tangent 45 minus tangent 30 all over 1 plus tangent 45 times tangent 30. I know their values. So tangent 45 is 1. Tangent 30, 1 over square root of 3 over 1 plus 1 times 1 over square root of 3. When you'll get square root 3 over 1 over square root 3 plus 1. That's your result. Okay, the last one. Cosine negative 75. So that's negative angle identity. So you know the identity, you have negative insides for cosine. So it's gonna be equal to cosine negative 75 is going to be equal to positive cosine 75 degree. So I can think about 75 as 30 plus 45. So let's apply the formula, apply the identity. So it's going to be cosines together, cosine 30 times cosine 45. The sign here is addition plus the operation is addition here. So in the expansion it's going to be subtraction since it's cosine. Minus signs together. Sine 30 times sine 45. So cosine 30 is square root 3 over 2. Cosine 45 square root 2 over 2 minus sine 30 is half. Sine 45 is root 2 over 2. So it's square root 6 minus square root 2 over 4. That's it. This is first part of the section. The other part, using the Pythagorean theorem with sum and difference identities, that's also very important. You are given sine of A in the given interval. You are given cosine of B in the given interval. So in order to find these identities, in order to write these expansions, you need to know not only sine A, but also cosine A. Not also cosine B, but also cosine A. So you are given one of them, you are going to find the other one by building a triangle in the correct quadrant for each. So for the first one, sine A between 180 and 270. Between 180 and 270, which means it's in the third quadrant. In the third quadrant, here is my angle. It must be adjacent to x-axis. Be careful about that. You are given sine. Sine means opposite over hypotenuse. So your opposite is negative 12. Hypotenuse is 13. What is the missing side? You can find the missing side by using either Pythagorean theorem, x squared plus 12 squared equals 13 squared, or you can recognize the spatial triangle. Here we have spatial triangle. 12, 5, and 13. So this side is 5. If you don't know that, just use Pythagorean theorem. So what is your cosine then? Your cosine here will be adjacent over hypotenuse. Oh, so one more thing that I want you to be careful about. Here the sign is important. At 5, it's okay, but since it's in the negative direction, the sign must be negative here. Make sure that you are using the correct sign. So cosine A will be negative 5 over 13. What about tangent? Tangent is opposite over hypotenuse. So negative 12 over negative 5. Negatives will go. So 12 over 5. That's it for the first one, for angle A. What about angle B? Angle B is located between 90 degree and 180 degree. So it's in the second quadrant. Here is your angle. Make sure that you put the angle in the correct place. It's not adjacent to y-axis, it's adjacent to x-axis. What's given here? Cosine is given, which is adjacent over hypotenuse. Your adjacent here is negative 4. Hypotenuse is 5. What about the opposite side? You don't know the opposite side. You can use Pythagorean theorem. 4 squared plus x squared equals 5 squared. Or just recognize the spatial triangle. Here we have 3, 4, 5 triangle. What can you say about the sign of 3? It's in the positive direction, so it's positive 3. Sign here is positive in the second region, so it's positive. What we are given here is cosine, so we need to find sine and tangent. Sine B, opposite over hypotenuse, so 3 over 5. Tangent B, opposite over adjacent, 3 over negative 4. So we found everything that we need to solve these questions. So let's start solving them one by one. Question 9. Let's write the expansion. Sine A times sine A times cosine B plus sine B times cosine A. So sine A, we were given this as negative 12 over 13. We got cosine B, cosine B is here, negative 4 over 5, plus sine B, we found it as 3 over 5, times cosine A, we also found it as negative 5 over 13. You can do all these steps, so it will result in 33 over 65. Let's do the same for cosine A minus B. Cosine A minus B, we can expand it as cosine A times cosine B. And we have subtraction here inside, so we will have addition in the expansion. Plus sine A times cosine B. So cosine A, we found it as negative 5 over 13 times cosine B were given to us as negative 4 over 5 plus sine A, we were given as negative 12 over 13 times cosine B, we were given as negative. So I made a mistake here. It was supposed to be, this was supposed to be sine B. So times sine B, sorry. So what was sine B? We found here it as 3 over 5. So I leave the calculations to you. So let me write the result. The result is negative 16 over 65. That's it. You can do the same for tangent a plus b, a minus b, because we already found tangent a and tangent b by just substituting them into their places.